Okay, this is the video solutions for the quiz 5 from Math 0110. Okay, first question. We're asked to find a value of x that makes something happen. So this is not a derivative question. You should ask yourself that before you solve any problems on any type of calculus-based math course. Not every question requires you to take a derivative. What you have to do instead is rearrange the expression to get the x value that makes it true. The strategy that I follow to do these is if there's an exponential function involved, I try to get that all by itself first. If there's a log function involved, I try to get that piece isolated first. So get the function part first. The part that contains x, get that all by itself, and then either log both sides if the x is trapped in an exponential, or exponentiate both sides if the x is trapped in a log. So let's see what that looks like for this example. We have 4e to the 2x minus 1. Minus 1 is equal to 5. What I'm going to do first is I'm going to add 1 to both sides. So we get 5 plus 1, 6. Now the exponential function, e to the 2x minus 1, is multiplied by a 4, and I don't want that 4. So I'm going to divide both sides by it now. So e to the 2x minus 1 is equal to 6 divided by 4. And you can reduce that fraction if you want. It reduces to 3 over 2, but I'm going to leave it. You don't have to. Next, we have an exponential function that has an x trapped, and the exponential function is now isolated. So the sensible move to do is to log both sides. And the log base we're going to use is log with the base of e. We want to match the bases. The base of the exponential we match with the base of the log. And log base e has a short form, ln. So ln of e to the 2x minus 1 is equal to ln of 6 over 4. On the left-hand side, we have ln e. So log base e of e. The cancellation law allows us to cancel the ln and the e. And what we're left with on the left-hand side is just 2x minus 1. And that's why we did that. Because we wanted to have access to a cancellation law. Next step. So now I want to get x all by itself, and it's not trapped anymore. So I'm going to add 1 to both sides. We cannot bring the 1 into the bracket. It's not allowed. The 6 over 4 is being protected. Inside the log function, you can't bring numbers in. And the last step, divide both sides by 2. So ln of 6 over 4 plus 1 all divided by 2. And I'll put an or here. You may have simplified your fraction, so I'll just write that in. 3 over 2. Ln of 3 over 2 plus 1 all over 2. That's as simple as it gets. Okay, next question, number 2. Find the first derivative of that thing. F of x equals. Now this one's a derivative question. It's asking for a derivative, so you have to find f prime. The trick, the part that's most likely to be something that you could miss, is the product rule. I know I harp on this a lot in class, but it's important. It's important to identify what the correct strategy is. I'd argue that the strategy part's more important than the derivative rules themselves. Anyway, f prime of x, if we have two functions multiplied together, a and a b, the derivative will be a times b prime plus b times a prime. So a, x squared plus 1, b prime. So I'm going to write down some rules that we're going to use for derivatives as they come up. If we're taking the derivative d by dx of a function e to the power of w, then our derivative will be e to the w multiplied by w prime. So here we have e to the 4x multiplied by 4. since the derivative of 4x is 4. Plus b times a prime, so e to the 4x multiplied by the derivative of x squared plus 1, which is 2x plus 0. You don't need to write the plus 0. Okay, and it only wants the first derivative, so we can stop there. If they wanted the second derivative, we would simplify. And it would be much to your advantage to expand, then collect like terms, and then factor. If they wanted f double prime, but they don't, so we can stop there and leave the mess. Question 3. We're asked this time for a second derivative of a function also involving e, exponential functions with the base of e. So here we go. We're going to do the first derivative. We don't need a product rule here. We have two functions that are being added together, so a product rule is not necessary. Product rule is only for two functions being multiplied together. So we have 2 multiplied by the derivative of e to the 3x, which is e to the w times w prime, so e to the 3x times 3, plus another e to the w derivative, 3 times e to the w, so e to the negative 2x multiplied by w prime. In this case, w prime is negative 2, the derivative of negative 2x. We really should simplify before we do f double prime. So simplifying means combining the constants. 2 times 3, 6, and then e to the 3x, plus, well, minus, because we have negative 2 times 3, so minus 6 times e to the negative 2x. Okay, now we're going to do the next derivative. So f double prime, we have 6 times the derivative of e to the 3x, that's going to be e to the w times w prime, e to the 3x times 3, and then 6 times the derivative of e to negative 2x, that's going to be e to the negative 2x times negative 2. And then I'll simplify, even though we're done, we're not asked for a third derivative, but if we were asked for a third derivative, you definitely want to simplify the constants. 6 times 3, 18, e to the 3x, and then negative times negative positive, 12, e to the negative 2x. Okay, that'd be the answer for that one. And again, full marks for not simplifying, just for the previous line to that. Okay, number 4. This one requires a different derivative rule than what we've used already, so I'll write that down. If we're taking the derivative, d by dx, of log base b of a function w, what we'll get is w prime over w times the log of the base. You have to memorize this. So that's our formula that we use for the derivative. Here we go. So recognizing that it is of that form, now this is log base 10 for function w. Our derivative will be w prime over w times the log of 10, since 10 is our base. So downstairs we have the w function, x squared plus 6x times the log of 10. Upstairs we have the derivative of x squared plus 6 times x, which is 2x plus 6. That's your answer. Okay, last question, number 5. Find the slope of the tangent line to a function at a point, and then write the equation of the tangent line. So for the slope, m is equal to f prime evaluated at 1, at the x-coordinate of the point. So we have to find the derivative of f of x. I'll write that down here. F of x equals 1 plus 2x times the log of x. And then once we find the derivative, we want to evaluate it at 1. Now, as the quizzes were coming in, I noticed a lot of people did this one wrong because they missed the product rule. It's the usual thing. You have to look for them. This is an A times a B. So when you take the derivative, here we go. We have the derivative of 1, which is 0 because it's a constant, plus A times B prime plus B times A prime. So that's going to be A is 2x, B prime. B is ln of x. We haven't used this rule yet, so I'll write it down. D by dx of the ln of x is 1 over x. So we'll use that there. So we get 1 over x for the derivative of ln of x plus b times a prime. Ln of x is b, and then a prime, the derivative of 2x, is 2. I'm going to simplify. So in the first term, we have 2x multiplied by 1 over x. The x on top cancels with the x on the bottom. We get 2 plus, and then the second piece, I'm going to put the 2 in front of the ln of x. Now we're going to evaluate. So we get our slope m is f prime of 1, which is 2 plus 2 times the ln of 1, which is 0. 2 plus 0. Ln of 1 is 0. So I'll write that down as well and explain why. Ln of 1 equals 0. Why? So here's the reasoning. Say we don't know what ln 1 is. Ln 1 is equal to unknown. I'll call it A for the answer. What we would do, or what we could do to rewrite this, is exponentiate both sides, just to see if we can get some insight into what's going on. So I'm going to raise both sides as powers on a base of e, because this is a log function of the base of e. So we have e to ln 1 is equal to e to the a. The e ln cancels, so 1 is equal to e to the a. And we're looking for what power do we raise the number e to in order to get 1? And the answer is 0, since anything to the 0 is 1. Or almost anything to 0 is 1. So let me change that to red here. We get 0, 1, 1 is 0. So our slope is 2. So that's a part of our answer. Now we need the second part. Now we're going to write the equation of the tangent line. That's going to go in down here. So our equation of any line is y minus the y value, which is 1, equals the slope m, which is 2, times x minus the x value, which is also 1. And that's our answer. But in general, so we'll write down a more general formula. Tangent line through the point A comma B with slope m, that will be given by y minus b is equal to m times x minus a. So that's the more general, that's the general formula. I'm writing that because this example is a little misleading. The x value and the y value are the same. They're both 1. Okay. Bonus question. Not a derivative problem. You're not taking any derivatives. You're not using any special derivative laws to answer this. You're looking for the value of x that makes something true. And you have two approaches. I'll do the easy way first and then the hard way. Here's the easy way. I'm going to write it down. Just rewrite the question. So 2 to the power 5 plus the ln of x is equal to 8. So you think back to what we did before log functions came and kind of contaminated our course. I think those were the happy days, before logs. And when you had a question that looked a little bit like this, like let's say 2 to the x plus 1 is equal to 8 to the 3x minus 7, what we would have done is we would have tried to express both bases as the same. So in this case, we would try to write 8 as 2 to a power. And we can. It's possible to do that. But if that wasn't an 8, that was a 7, then we couldn't use this method. So 8 can be written as 2 to the power of 3. Now, I'm going to write a thought bubble off to the side again. If you were told that 2 to the power of a is equal to 2 to the power of 5, that's a guarantee that a must be 5. So if you had that, there's clearly no alternative. The only way that that statement can be true, the only way that the equal sign can be correct, is if a is 5. And the same thing's happening here on the left-hand side. That we have 2 to a power is equal to 2 to a power. The only way those two things can be equal is if the powers are equal, both because the bases are the same. So 5 plus the ln of x is equal to 3. Now we can rearrange. Subtract 5 from both sides. So ln of x is equal to -2. That's okay. You can't take the ln of a negative number, but the ln can be negative. It can output a negative y value. We want to get x all by itself. Currently x is trapped in a log function with a base of e, so I'm going to exponentiate both sides as powers on a base of e. So e to the ln of x equals e to the -2. X's cancel, or the e ln cancels rather. So we have x is e to the -2, or if you like, 1 over e squared. Using exponent laws, you can always turn a negative power into a positive power downstairs in the denominator. Okay, that's the easy way. Here's the hard way. Colors. I'm going to use pink. Hard way. So I'm going to rewrite the question again. 2 to the 5 plus the ln of x equals 8. And you could just ln both sides. So take the ln of the left side, take the ln of the right side, or log base 2 both sides. Any base that you want, or log base 8 both sides, doesn't really matter. I'll use log base 2. Log base 2 of 2 to the 5 plus ln of x equals log base 2 of 8. And then on the left-hand side, we can use a cancellation law. Log base 2 of 2 to the power cancels. And we're left with 5 plus the ln of x equals log base 2 of 8. Okay, let's keep going. We want to get x all by itself. So the ln of x part's the important thing to isolate. Ln of x equals log base 2 of 8 minus 5. And then we need to get x out of there, so we're going to do what we did on the left-hand side. We're going to exponentiate both sides. Again, base e, because we're trying to untrap the x from a log function that has a base of e. So e to the ln of x equals e to the log base 2 of 8 minus 5. We don't get any cancellation law on the right-hand side. We only get one on the left-hand side because the bases match. So we have x equals e to log base 2 of 8 minus 5. You can't cancel that. That's a perfectly acceptable, wholly unsatisfying answer. Now you could convert this one into the one on the left in the following way. So e to the log base 2, and then can you write 8 as 2 to a power? And yes, you can write it as 2 to the 3. Now you can cancel Log base 2 of 2 to the power, that's perfectly fine to cancel out. That's legal. So e to the 3 minus 5, also e to the negative 2. So in class, I like to go through and show you the easy way to solve the questions, but there are an infinite number of pathways you could take to get the answer. So here's 2 of them, but there's many more. You could take the log base 8, take ln on both sides. Possibilities are endless. Okay. The other code had some different questions. Some of them are the same, some of them are different, so I'll go through those as well. Number 1, asking to solve for x. So this is a different version, but same idea. X is currently trapped in a log function. So what we should be looking for is a way to get the ln function first isolated. So ln of 5x is equal to 10 divided by 3. Divide both sides by 3. Now we have x trapped in a log, and the log is isolated, so a good move is to exponentiate both sides. I'm going to use a base of e because we're untrapping the x from a log function with a base of e. So e to the 10 over 3. On the left hand side, the e ln cancels. So we have 5x is equal to e to the 10 over 3. And then we want to divide both sides by 5. So x is equal to e to the 10 over 3, all divided by 5. Okay. Number 2 is the same as the previous code. We'll go through it again. Number 3 is almost the same as the previous code. It's a little bit different. There's different numbers, but I'll go through it. So it's a derivative question. We're using the e to the w times w prime for each piece. So we have 5 multiplied by e to the negative x times the derivative of negative x, which is negative 1, minus 2 times the derivative of e to the w times w prime. So e to the negative 5x, that's the w part, times w prime. Derivative of negative 5x is negative 5. Before we continue, we should clean up the constants. Negative 1 times 5, negative 5, e to the negative x. And then the second piece, negative 2 times negative 5, positive 10, e to the negative 5x. Now we're going to do the second derivative. So we have negative 5 multiplied by the derivative of e to the negative x, which is e to the negative x times negative 1, plus 10 multiplied by the derivative of e to the negative 5x, which is e to the negative 5x times negative 5. And then clean up the constants, even though we don't really have to, because we're not doing the third derivative. Negative 5 times negative 1, positive 5. And then 10 times negative 5, negative 50. Every time we take a derivative, in the first one, a negative 1 comes down, the second one, a negative 5 comes down. Okay, number 4 was the same, number 5 was the same, and the bonus is a little bit different. Same strategy, but different numbers. I'm only going to do this one the easy way. You can do it the hard way if you want. It's possible to set both bases equal to each other. So we can write 27 as 3 to the power of 3. 3 times 3 times 3 will give you 27. And then since the bases are the same, the powers must be equal. There's no other pieces involved in the expression. If we had like a plus 1 on the right hand side, we couldn't do this. We'd have to use a different strategy. So 7 plus the ln of x equals 3. Now subtract 7 from both sides. Ln of x is equal to negative 4. And now exponentiate both sides. And we're going to use a base of e because the x is trapped in the log function with the base of e. So we can cancel on the left. We have x is equal to e to the negative 4 or 1 over e to the 4. Okay, and that's it.